Hello again, this is Mikko Korpela, and this is the third part of Pabot and programming a new feature to it. And in this case I'm going to basically focus on fail fast principle, which in my opinion is one of the most important stuff that you have to basically know as a programmer and as a developer. So you have to validate as fast as you can that you are doing the right thing. And later on, of course, you have to do the things in the correct way, but most of things that I try to validate is, am I really solving the right puzzle? Is this going to solve the right puzzle, etc. And then there's going to be, at some point I will also go through this systematically, going through every case thing, which is another thing which is very, very important about programming. But yeah, let's continue from where I left off like 2-3 weeks ago. So last time I did this little piece of code where I did this suite names, and it stores. If it's not yet there, then it will actually generate the suite names, and the file is then used to execute the actual test cases. And now in this particular case there is one thing that I'm actually able to falsify now. So my guess, or my initial guess, has been that once I have this list of names and I read it and execute this code, it should be faster than just actually generating the names list. So this is something that I can falsify now, and in the name of the failing fast thing or the principle, I will do it. So we will go to the solve suite names part here. I will put the font a bit bigger. So this is the code that we are currently executing, and we want to compare basically that this has to be faster than the code that doesn't do this, or the original code. And to do this I'm going to import the time module, and I'm going to record the time that when this operation starts, and then I'm going to just print out the difference in time until the end. Okay, so that's all I'm going to do. And this should give me a method to basically validate if this is actually faster, or not to validate that, but if it's not faster, then this should show it. So now it took like 5.4 or something and 9.0 something. I will execute it like 3 or 4 times. So it's fractions of a second, very, very small fractions. I will just record these. So these are now the basically some results for situations where I already had the suite names file and I just executed this. So this is the happy case. But yeah. And the easiest way to just check out that this is actually, or if this is slower is to just to remove the Pabot suite names file, which will do this storing and generating of suite names. So in any case, that should be a lot smaller, or should consume a lot of more time. So let's see if I just remove that. So now I don't have the suite names, and then if I try to execute the same test case. So okay, there you go. It took like 0.2 seconds. So that's kind of obviously this is a lot larger than 6 to the e 6.0 e. Yeah. So this kind of gives me some confidence that the way that I'm solving this is going to make a lot faster implementation. Then let's try another one. So the original one was just doing this generate suite names, which is this part. And let's just check out that if this would still be like this, store suite names. So this was just directly use this generate suite names. So names. Oh. And then we would use that there. Yep. Then this is the third one. So this should also be a lot slower than this implementation that I'm currently making. So let's just check out that. Okay. So that's like a lot. Yeah. Another big number there. Yeah. So evidently the version that I'm doing is a lot faster. So that means that I haven't yet failed, unfortunately. So let's just put this all back like it used to be. So now this is my version, so it's again a huge massively efficient version. All right. Then we have to continue. So this is, although it's massively like more efficient, currently this actually has bugs in it. And one way to identify or one way to show this is that the new list is only generated when the old list doesn't exist. And this is totally false assumption. So for example, now we have in the list we have all these suites, but if I go to the TMP file and copy one of these test suites to make another test suite number 6, what will actually happen now is that the test suite number 6 is never executed. So the implementation, the actual implementation should update the list whenever something gets added to the test cases. So that is one thing that we need to remove or change here. So I'll just mark it as a comment here. So to do should, well, let's say should regenerate the list when a new suite is added. Yep. There is also one other thing. So if we actually remove one of the suites, do this again. So suite number 4 was removed, and now it says that suite number 4 failed. So let's see what was the cause. Okay, it's not shown here at all because it actually doesn't exist, and that's the cause of the failure. We can also go to the Pabot results. Where is it? Pabot results, and TMT test suite, and see what the standard error looks like. Okay, the TMP contains no test suite with the name. Yeah. So basically, this is another situation we need to resolve. So should regenerate the list when a suite is removed. And actually there's even a third one. You can, these are kind of like create, read, update operations. These are so common that I can just go through them. So, well, reading is not a problem here, but whenever something gets created, we should regenerate. Whenever something gets deleted, we should regenerate the list. And also whenever something gets updated, we should also regenerate the list. So, for example, you might remove some test case or some tag from a test case, and after that test case or that test suite would not be anymore in the suite as to be executed, or whenever a tag gets added, then a new suite actually might be in the lists of suites that should be executed. So should regenerate the list when a suite is changed. So these are the 3 cases that cover everything basically from the point of view of the execution directory. There are also other things that we need to consider. So this is just the first systematic going through everything. So also we should consider what the actual command of execution is. So I can basically exclude some suite here, tmp test suite 3. Okay, that went to wrong thing. Yeah, I should actually fix that bug also. So this has to be here. TMP test suite 3. So now what actually happens is that we have this exclude, but instead of excluding it, we are actually running it. Oh, now I have to just check out that I'm actually using the right method. Oh, that's the tag one. I bet there is one where I can use directly to exclude some test case or test suite. Exclude. Yeah. Okay, I have to use tags to do this. Okay, let's put that in there. So let's put in here that we have a tag. Settings. Tags. Exclude this. I think that was the syntax. I have to check that out. So, robot framework, documentation, user guide, view, tags. Okay, it's called default tags. Okay, like that. So now we should have the default tags here. Oh, and let that exclude this. What is that? Yeah. So that should exclude it. But it doesn't. And if we are running with Pabot, no, can't remember the correct syntax now. Well, then it doesn't actually apply to this. See, there should be a tag. No. Ah, yeah. I think I have wrong setting name currently. Yeah. How silly of me. No. Okay, now it excluded the third one. And what happens with the Pabot one? Okay, the test case actually fails now. And what else we can do? So that is an example of a case where actually the command that we are executing is changing. So we should regenerate the list when execution command changes. So if something is changing the execution command itself, like you add an exclude or include something or something like that, then we should also regenerate the list. Yeah, and then there's for the completeness sake, there is also a case where these arguments are coming from an argument file. So when an argument file is changed, we should also regenerate. Yeah, these are the 5 things I think we need to add before actually calling this anywhere ready. But yeah, so these 3 firsts I think are most easy to do, and how I would do them is by making basically a hash from the directory. So check directory hash. So we can hash all that is inside the switch directory that we are executing, and if that hash is still the same as last time, then we know that nothing has changed, because this basically, these 3 say that if something changes, then we have to make or regenerate it. Yeah. Then actually there is still a thing that we have to consider. So we should also actually check that what will happen when the Pabot suite names file is changed. So if somebody manually edits this, then we should first of all realize that is happening, and then we should act on it. So check. So I'm just going to make a hash about that also. So the Pabot suite names hash. There has to be a hash about that. Also we have to have a hash about the execution command hash. The hash is a kind of cool way to just solve these. I think this can be included in this. So I think there's going to be like 3 hashes that have to be added to the Pabot suite names. Just quickly going to browse on how to generate a hash for a directory. Directory Python. Let's see. How do I call it for a file system directory? There should be a ready-made way of doing this. Yeah, the files needs to be sorted. And how is this doing? It's using some hash lib. Is it always available? Yeah, it's a basic hashing start. Okay, yeah. But yeah, I will continue from this point on next time. Thank you. Time's up.